Okay, this lesson is a review of exponents, which you've gone over them in 5th and 6th grade and in pre-algebra. So we're going to practice writing and simplifying expressions that have exponents in it. So there's a bunch of vocabulary that we need to go over. So in the expression 5 to the 4th power, the number 4 is called the exponent, and the number 5 is called the base. So this is my exponent, and this is my base. Okay, we call 5 to the 4th power the exponential form of 5 times 5 times 5 times 5. Okay, so this is the exponential form. So if you have an exponent, it's in exponential form. The exponent tells you the number of times the base is used as a factor. So here 5 is my factor. It's the number that's being multiplied, and it's a factor 4 times. 1, 2, 3, 4. Okay, so that's what the exponent tells you. So if I have this and I say, please write this as a product of factors, you would write it like this. You would say 5 times 5 times 5 times 5. And if I say write it in exponential form, you would write it like this, 5 to the 4th power. And if I say what is the value of this, you would actually have to multiply it out. So it would be 625. Because it would be 5 times 5. These are 25. These are 25. 25 times 25 is 625. Okay, so these are different ways you might be required to write them. Product of factors, exponential form, and then the actual value. Okay, so here we have, in general, if b is any real number, okay, and n is any positive integer, so we're going to start off by talking about just positive exponents. The nth power of b is written as b to the n. So we call this the nth power of b. Okay, which is just craziness. If you think about powers of 10, yeah, powers of 10. So let's talk about powers of 10. Powers of 10. So a power of 10 is anything where 10 is your base and your exponent is just whatever it is. The cool thing about powers of 10 is that they're really easy to find the value. It's basically just 1, and then the exponent tells you how many zeros. So 10 squared is 100. 10 times 10 is 100. 10 to the 6th is 1 million. 10 to the 7th would be 10 million. Okay, and it just works out that way, that the exponent is the same as the number of zeros. So if you have anything that's to the power of 10, it's pretty easy to find. And if you have a number and you need to write it in exponential form, it's pretty easy. You just count the zeros, and that's your exponent. We're going to use powers of 10 again when we do scientific notation, okay? But it's important that you understand powers of 10 before that. Okay, so let's look at some examples here. We need to make sure that we're following the order of operations. Okay, anytime we're doing anything with exponents, you take care of the exponent first. Okay, GEMDAS. G is for grouping symbols, E is for exponents. So before we multiply or add or subtract, we need to simplify those exponents if at all possible. Okay, so this says write this in exponential form. Okay, with exponential form, any numbers that are just regular numbers, like this -2 and this 3, they get multiplied. Okay, so -2 times 3 gives me -6. I then look to see, I've got P's and Q's. So I'm going to see how many P's I have. I have 1, 2, 3. So it's P to the 3rd power. And Q's, I've got 1, 2, Q to the 2nd power. In algebra, we write our variables in alphabetical order. Okay, so write variables in alphabetical order. Okay, and the reason for that is you're going to have times when you've got a whole bunch of terms that have different combinations of variables. You might have 2 or 3 different variables, and in order to figure out which terms are like terms, it's very, very helpful if you've got your variables already in alphabetical order. It just makes it easier to figure out. And mathematicians like things nice and orderly, so anytime you've got letters involved, we go by alphabetical order. Okay, so here we have a rectangle. and it's a lovely rectangle. And the length is 3x and the width is x. And they want to know what the area is. So it's going to be 3w times w, okay, because it's length times width. Well, w times w is w squared. So 3w squared is my area. Notice that there's no more dots indicating multiplication. I don't have anything in parentheses. It's just one term, 3w squared. Okay, and then we have this problem that we need to evaluate. And it happens to be the base is -5. So when I write this out, I'm going to write it like this. Okay, because it's -5 is being raised to the third power. Okay, so -5 times -5 is +25. And +25 times -5 is -125. Okay, we have this nice glaring warning here. It says, be careful when expressions contain parentheses and exponents. So let me show you an example. If I have -3 to the second power, and I have -3 to the second power, these are going to give me two different answers. -3 times -3 is +9. This is saying the opposite of 3 squared. Well, 3 squared is 9, so this is going to be -9. So be super careful with your parentheses. If you have something that's raised to an exponent, only that thing is raised to an exponent. So if you want this negative to be part of the 3, and the -3 raised to that exponent, then you need to put it in parentheses, and the exponent needs to go on the outside. So be super careful. This really doesn't it's especially difficult when you have, not difficult, but important when you have negatives. Here's another example. Suppose I have 2x squared and 2x squared. Here, the 2 is being squared and the x is being squared. So 2 squared is 4, x squared is x squared. Here, it's just the x that's being squared. Okay, so be super careful with your parentheses. Okay, so then to try this, you've got a rectangle, you need to find the area. This they want you to write in exponential form. Remember I talked about what exponential form is? This they want you to simplify. So basically they're looking for the value. So you should come up with a single number answer for that one.